All right, folks, we're back, and we're going to be talking about our Brick Breaker project, and this time we're going to add in the paddle. It's another class, just like our ball class, and it's going to have well, I guess it will have a lot of similarities. I'm going to make my paddle just controlled with the mouse, and I think that'll be fine. Our paddle is going to be a circle because circle-on-circle collisions tend to be straightforward, and we've done them for many projects, so I think we'll keep on doing them. So let's start. I'm going to make class paddle. And our instance variables are fairly dull in this case. Let's see, I guess I have x and y, but I'm going to control this with a mouse, so it doesn't really have a vx and vy, but you could make it so that you use keyboard and you have vx and vy, so it's going to be up to you to decide those decisions. I don't mind. This is the simplest one, so I'll do that for our demonstration, and you can choose to get fancier if you wish. Paddle is our constructor, and I'm just going to set the default values. Y is going to be like the height, but probably plus a little bit more. I don't know, like plus 40 or something. Actually, maybe I'll make a diameter as well for a paddle. Let's give ourselves a diameter. And then this might be worthwhile to be a fraction of the diameter. I'm just going to rough this out. It'll be good for now. We can come back and change it. Where's the x coordinate going to be? We'll stick it at width, I suppose, divided by 2. And then the show function. I guess we need to set a diameter, sorry. I'll set it to be 200, I guess. That'll be a good start. So now I'm going to have void show. Show is going to be our function that will show the paddle, draw the paddle. We're just going to use an ellipse. You can change this to a picture or whatever you want later on. And that's going to be at x and y and d and d. And then we're going to, have an act function. The act function is going to be just moving it. And the way we move it is to set x to mouse x. And that way as we move our mouse around, it will follow. Because x will constantly be updated. So that will draw our ellipse. You could just stick mouse x in there, I suppose, but we'll stick with the show and act. And maybe later on there'll be more fancy act stuff going on. So if we run this, just like before, we won't get a paddle, right? Because this is a class and not an actual thing. We'll probably get some errors as well. Whoops. Yeah, there's our ball. No paddle. Uh-oh. So what do we do? Same thing that we had to do with the ball. We actually have to go and make a paddle variable of type paddle. I'll call it my paddle. And we got to instantiate it. So you're calling the constructor. So new paddle. And then in the playing function, we actually have to make it show and make it act. There we go. Now we'll have a paddle. Here goes our paddle. Woo! Of course, there's no bouncing happening, unfortunately. So we're going to think about a way to make that work. So that's pretty straightforward. We've already done that math. It's going to be a circle-on-circle collision. But there's a new challenge, and that is, where do you put that code? We used to put it in the playing function, but like, how do you talk about the balls x and y and the paddles x and y and the diameter? Where do we put it? Is it something that the ball does? Is it something that the paddle does? It's not really clear. So I would recommend that if you are trying to figure out where to put collision code, think about what is going to react to this collision. Sometimes multiple objects will react to the collision, but in this case, really only the ball is affected. We want the ball to bounce off of the paddle. The paddle doesn't bounce off the ball, so it'll be a good place to build it in. So all balls know how to bounce off of the paddle. So what you can do is you can use your formula for determining whether circles are colliding. That's compare the distance between the center of the two circles, oh dear, to the sum of their radii. And if it's less, then you have a collision. All right, that's the story. This is what we've been doing for a while. So you might be able to code that up pretty well. When you're in the ball tab, X refers to the ball and Y refers to the ball, its position. But how do you refer to the paddle? Because we got to find the distance between the center of the two circles. So how do I say like the distance between like the X and Y of the ball and the X and Y of the paddle? It's not going to work. So the story is that you use X and Y for the thing of the class that you're in. So if I type X and Y, that is the ball's X and Y. But if I want the paddle's X and Y, I just refer to which paddle, and we're using my paddle. My paddle? Why my paddle? Well, because I made my paddle variable over here. It's called my paddle. Well, that's why it's my paddle. So my paddle, and then what? Dot X. My paddle dot Y. And I can say if it's less than the sum of the radii. I coded up my radii. Well, I coded up diameters, right? So what's a radii? It's just or what are the radii? It's the diameters divided by 2. So I can do d divided by 2 plus my paddle dot d divided by 2. There you go. That's the story. You can just manually add these numbers if you want to, but again, we're trying to make our code a little bit more flexible. So if we were to change the numbers, all of our code just works with that. So that's the story. So hey, if we have that, we have a collision. So what do? Well, we need to bounce the ball in the right direction that bounces off the circle. So now that I'm feeling sick, I'm realizing that, pardon me, I have to think about the math a little bit. But basically, it's like Pong. It's exactly like Pong. So you could just do the same type of math there. We're going to recalculate a Vx, and it's going to be the difference of the x coordinates of the ball and the paddle, and then divided by some factor to make it a reasonable size of velocity, a reasonable magnitude of velocity, I suppose is the right way to say that. So we're going to do x minus my paddle x dot x, and then we'll divide that. Excuse me. Maybe I'll times it by 0.1 or something. The same thing as dividing by 10. Vy will equal y minus my paddle dot y times 0.1. I don't know if that's the right number, but I'm going to try it. So it just recalculates our velocity based on a line between the centers of the circles when they collide. Let's see, does that work? Hey, look at that. It is a pretty strong bounce, and that's nothing wrong with that. The game is boring if it's too slow, so I think I'll just leave it as that, and it works pretty nicely. I'll get into the corner. Now this is unfortunate. Check out this little error here. I love this. I love this error, and we can fix it with some programming for sure. It's basically just constantly bouncing, and the Vy is not enough to get it out of the bouncing zone of the ground. But we can also, well, I guess we can whack it really hard. Maybe it's a feature, not a bug. Or we could just submerge our paddle a little bit further below. The reason that can happen is because, where is it? Sorry. Yeah, this is the ball. Because the ball, when it hits the side of the circle that's right along the bottom edge, well, it can pretty much put it horizontal. So if we make it go down further, like 100, we'll have a smaller paddle. Oh, 100 was too much. 60. We'll have a smaller paddle, but it's harder to get that like 90-degree collision on the side, right? So this is a little bit safer. Oh, I missed. And if this makes your paddle too small, well, you can just increase the diameter. Maybe I'll make it 250, and you can kind of adjust the depth of it and such. So you can keep on working till you get a good number that you want to. And notice that my collisions and everything are working, even though I resized my paddle. Everything just worked. Isn't that phenomenal? I really feel like that's a major achievement. And the reason is because I'm using this D variable and in the ball and in the paddle. And then all of our code is based on using D. And then, D is in the collisions. D is here in our collisions as well. It's all over the place, and so I can just type in new numbers for my diameters and just experiment with things. And later on, when we're bouncing our ball, we want to make the ball grow big or something. Like maybe that's going to be a power up. Like, it'd be nice if it automatically just calculated those collisions perfectly. So what a time to be alive when we can make these things happen. It's really good. So for the rest of the class, you guys are going to have some stuff to do. You got to make this happen, of course. Get that working on your computer. But also, because of a way, that's about all we can do. And we're going to also have you guys work on things like your intro screen, your lose and win screen, which right now are pretty bland. You start spicing up the graphics of your balls and your paddles and such. So, instead of just an ellipse, you can change things. Or at least, get it out of being black and white. Start getting a color palette going on, maybe from colorlovers.com. If you want, you can take a stab at making some bricks. The bricks are just going to be circles. They're not going to move. They're just going to sit there. But you got to lay them out in a grid. And they have to check if they're colliding with a ball. So that's a bit of a challenge. We'll look into that next class. But that's sort of the next big programming thing to do. But I'm sure you can fill this class with lots of useful things to get this project on its way. All right. Thanks, everybody.